Hello, and welcome to today's SANS Cloud Security webcast, the Threat Detection with Cloud API Logs, a case study from Capital One. With us today, we have Shaun McCullough and Ryan Nicholson, who are both authors and instructors for the SANS Institute in our cloud security curriculum. And if you have any questions for them throughout the presentation, please enter them into the Q&A and we will get to them at the end of the presentation. Thank you so much for being with us, and Shaun, take it away.
Thank you so much. I am excited to be here. As I say, my name is Shaun McCullough. We're going to take a look today at the Capital One attack that happened a few years ago and kind of break it apart a little bit. And then we're going to focus in on one way we can use the cloud to try and detect some of the things that happen inside of that attack. You could probably see it on the bottom of the screen, but this actually material is kind of built from a class that Ryan and I just finished working on, which is a 3-day Security 541, where you'll get a feel for how we do the class. We start every day with a case study of an actual attack, break it apart, figure out how we would detect, actually reproduce the attacks in the labs, and then evaluate it. So it's a lot of fun. And so this gives you kind of a little hint of what the class is going to be. So we're talking about threat detection. So we're looking at it from the perspective of figuring out what attackers will want to do into your environment, and then using that to try and figure out how do I protect it. So this would be different than, say, compliance evaluations. Like I'm sure you have PCI and other things that HIPAA you have to do. So you got to do that. That's good. There's also protections you put, like vulnerability assessments, like running some kind of tool inside your environment, figuring out, that, hey, this library is not patched, let's patch it. Those are great. Let's do that too. When I look at threat detection or threat focused or any of the kind of threat naming, I'm really looking at like figuring out, what do attackers do? What do they actually do? How do they accomplish their goals? And how do they hit people like me? So in my vertical, maybe not my company, but the companies I'm in. So if you're in healthcare, then you might have to focus on a different set of attacks than if you're, let's say, in government. So that threat focus is that idea of, hey, what are we doing? What are people doing to us? How can we protect it? How can we detect it? And so when we look at threat detection, we got to start with information. And there we go. All right, it worked. So threat detection really starts with this threat intelligence. This is information that helps inform you of what kind of threats, how do they operate, what are they looking to do, that kind of stuff. When I look at threat intel, I kind of break it into 3 pieces. There's what I call atomic indicators. This is things like IPs, domains, hashes, very specific pieces of information that says, if you see the hash of this file, because it's a bad piece of malware, then destroy it, right? Or if you see communication from this IP address, it's a known bad, command and control, block it. So atomic indicators are great because they tell you good, or well, they don't tell you good usually, they tell you bad, right? So bad, block. So that's great, have that information. Another kind of intel is kind of this idea of like statistical approach, which is a little bit different than intel, but really it's like, hey, if I look at all of my systems, I've got 500 of them, and one system has a file that nobody else has, I should probably go and investigate it. It's an outlier. Statistically, it looks different. I don't know what it is. It's more than likely it's a developer accidentally installing something that maybe you didn't know about, right? That happens a lot. Or it might actually be a piece of unique malware that has gotten onto your machine. So statistical analysis is another way of looking at it. I actually spend a lot of time and have fun looking at behavioral analytics. Or behavioral detection. This is a behavior that the attacker exudes inside your environment that is risky, is a problem. It's a bad thing. A lot of problems with these behavioral analytics is that the behavior is accepted, but it's being used in the wrong way. So case in point, remote desktop. So if you've got a remote desktop happening all over your environment, it would be hard to tell that an attacker is using remote desktop to interact, right? I mean, but that's a behavior that you can start looking for. So that behavioral detections and risks are kind of tough to figure out what's good and what's bad, and every environment's a little bit different. But there are a couple tools out there that kind of help us figure out how to look for certain behaviors or what behaviors attackers are exuding. Twitter is a great resource, but another one would be MITRE ATT&CK. So I'm sure a lot of you have, or many of you probably have seen MITRE ATT&CK framework and have used it before. I love MITRE ATT&CK. I've been using it, well, I've been using it before it was released publicly, but I love a MITRE ATT&CK because it really gives a good lexicon in order for you and me to have a conversation about something that can be kind of difficult to discuss. So for instance, we're both having a conversation. I want to say, hey, look, I'm looking for account discovery. You and I can go and look at the MITRE ATT&CK framework and we can kind of be on the same page of exactly what does that mean. I'm going to talk about attack real quick because we need to know about this in order to hit the rest of the slides. So if you use attack before, awesome. If you haven't, MITRE ATT&CK framework is laid out in this kind of grid format. Across the top, you see the dark gray. Those are what's called tactics. I consider them intentions of the attacker. So the attacker wants persistence, or the attacker wants to do a discovery, right? So that's the intention, the goal of the attacker. Going down the list is how they would do it. What are the techniques that they use inside the environment? So we're actually looking at the cloud matrix. If you can see on the left-hand side, there's a completely different matrix for Windows and one for Mac and mobile and ICS, all this great stuff. This one is for cloud. And so if you look at something like discovery, you can go down and you can see all of the ways that have been seen in the wild and as part of the matrix, different ways of doing a discovery inside of a commercial cloud environment. MITRE is always looking for suggestions and recommendations for changes and new tactics and techniques. So you can always go into their page and take a look. Every one of these boxes has an ID and it's like T1234, something like that. And so anytime that you're talking to somebody or reading a report and they say, hey, T1234, you can go back and look at the MITRE ATT&CK. All right, that's the setup for the Capital One study. So what we're going to do is we're going to walk through this attack that happened around March of 2019. We're going to break apart the different attack techniques that were being described. I'm going to reference the MITRE ATT&CK technique in there so that you can kind of see it and you can go back and look at it. In the class, we spent a lot more time on diving into each technique, but we'll just hit one or two real quickly in this webinar. So Capital One is a large financial institution. They're really claim to fame as the commercials and the credit card applications. And back around March of 2019, it was identified that an attacker had gained access to one of Capital One's environments and had retrieved over 100 million credit card applications. Most of them in the US, I think some of them were for Canada. And the attacker's name was Erratic. Well, that's what she went by online. And she exploited a public-facing application that was able to give her access and credentials to pull data from all of these these S3 buckets. All right. So how did she do it? Oh, and she was caught because I think she was talking about it in a discussion group and someone saw it and somebody else, I guess, notified Capital One and they went to go look at it. Capital One is actually a big major player and thought leader in AWS and cloud and for financial institutions. So even a large organization that has a lot of automation and does a lot of things right, you can see it just takes one problem to lose access to that 100 million credit card applications. So here's our board. What we're going to do is we're going to look at a 5-step process that Erratic used. And each one of these kind of boxes is you'll see it's kind of pinned back to the MITRE ATT&CK technique. Just for a frame of reference, on the left-hand side is the red console. That's the attacker's machine. So it's sitting outside AWS. And then inside of the boxed area is the AWS environment that she was able to gain access. Now, most attackers, the first thing they're going to do is they're going to scan your environment. That's T1595, sub 0.001. I won't read them every time, but just so you can kind of see what they are. So the attacker is going to scan an environment, and usually that's a network scan. Using the network scan really figures out what's out there, what's deployed, and what level of service is running. So there's a web server, and the web server is running, this set of code, that might be vulnerable. And that's kind of the method that she used. There's actually kind of three main ways an attacker gains access to a cloud environment. Being able to hit and exploiting a vulnerable web application is a big one. Another one is actually S3 buckets or other things being made public accidentally or on purpose, but not realizing what they're doing. We always read about S3 buckets that are being left open in the wild, right? I mean, you read about those all the time. So that's another way they can gain access. A third big way that they gain access is through identifying or guessing credentials. So there's been a number of cases where someone's username, password, or their token secret information is accidentally checked into GitLab. So that's a major problem. Or maybe it's a bad username and password, or maybe there's no username and password and it's some kind of vulnerable system that they gain access. Those are kind of usually the main three ways that we see attackers gaining access. But Erratic scanned the environment looking for a particular attack, and she found a vulnerable web app. That's the blue box in the middle. That's a virtual machine, an EC2. She was able to gain access to this web app using a server-side request forgery attack. So without going too much detail, let me just say a web application, if you can manipulate the web application, the input, so that the web application makes a HTTP call on your behalf, then you might be able to do things with that web application that you as an outsider normally wouldn't be able to do. And that looks like what she did. There was a web application firewall, looks like sitting in front. It was either misconfigured or it was not configured to block, only for logging. Or I think it may be possible that the web application may have been part of the vulnerable app. I'm not quite sure. It's not real specific in the write-ups I've seen, but whatever it is, she was able to use this web application and was able to make an HTTP call on the behalf of the web application. Now, I mean, who cares? It's not like she went to CNN. What she did is she hit something called the metadata service. This is a service that's provided to each virtual machine and actually any compute resource inside of AWS. And that metadata service provides some information about that virtual machine. So I've got a virtual machine. It's running some kind of application. It's a blog, let's say. And that application, that's blog, needs to be able to read from an S3 bucket to get configuration information, or images, pulling images. That would actually be a better one. So inside AWS and Azure, that virtual machine needs to be given permission to pull data from an S3 bucket. Okay. So in order for that to happen, the S3 bucket or the virtual machine needs to be able to ask a question: what are my token that I can use to interact with the AWS environment and go and pull the S3 buckets? The only person that can make that call is the virtual machine. It's not like it's a REST call to like some place in the network. It has to be done on that virtual machine. But with a server-side request forgery, she can make that web application perform that attack or that call on the behalf. So she was able to make that call, be able to get the token, and that is basically a key. And that key allowed her to pretend to be that virtual machine. And so what she can do is she actually can take those keys, bring them back to her workstation or just sitting on that host if she wants to, and she can do anything that virtual machine is allowed to do. In this particular case, this virtual machine was allowed to have access and read from the S3 buckets in the environment. My guess is this was a mistake. It was not intended to be able to read from all S3 buckets, but there was a problem with how it was deployed. That's just my guess because I've done that before. So I've seen that happen. Not that I've been hacked, but anyways. So the S3 bucket or the EC2 had permissions to read from the S3 bucket. So the first thing when someone gains access to a credential of some kind, whether it's username, password, or it's, in this particular case, it's the metadata services secret key information, the first thing they're going to do is a cloud service discovery. What services is this EC2 allowed to do? And turns out she could read from any S3 bucket. The next thing she would do is say, what are the S3 buckets? Let me use that privilege to say, what can these S3 buckets? And there ended up being an S3 bucket that had sensitive data. And so because she has the keys, she's able to bring them back to her workstation and then perform AWS S3 sync and start copying down the data. from those S3 buckets. So we have our attack. We've mapped out exactly how the attacker was able to do this. We even identified the attack techniques that are being used, and there's actually more, but these are the kind of the main ones. One of the things that when we talk about, and now we're, here's the attack, but one of the things that has happened is there's a lot of use of what's called the Cloud API service. When we kind of draw and think about how we're using our environment, I have a virtual machine or I'm a user, and that user has permission to read from an S3 bucket. And we usually think that that virtual machine is just going to the S3 bucket and pulling it back, just like it's going to a web server or going to a local network drive or something like that. But that's not the case. What's happening is it's going through an API service. You can tell that a professional graphics person did the slides a couple ago, and this is mine, right? Because it's bad. Anyways, the black line down the middle is actually the API. And so I have my virtual machine in blue, and my virtual machine is going to, number one, make a call to the API service that says, hey, I want to read from the config or the secrets S3 bucket. So I go through the Cloud API to do that. It goes to the S3 bucket service or the data store bucket service. And it says, oh, you have permission to do that. I'm going to go pull the data for you. And that's what that step 2 is. And then I'm going to send it back to you. And that's step 3. All of those interactions across the API can be logged. They may not all be logged every single time. That's kind of in the detail, but most of the things that happens inside the AWS service goes through this Cloud API. And so there's a service that both Azure and AWS have that gives you the ability to figure out what the logs look like. So you can see that line for number 1 and 3, you can see the interaction happening. And that is called CloudTrail in AWS, which I'll hit in a minute. But that it's not just S3 buckets, but it's almost everything you might want to do inside of a cloud environment. It's also all the things the attacker is going to want to do. So things like scanning for S3 buckets. We've already talked about that. Creating a new user that has over permissions and gives the actor, access to the environment. Changing a policy so that, now it's not just an EC2 can read S3 buckets, but maybe it can read everything like virtual machines or whatever. Stopping logging. That should be a red flag. Your logging should never stop inside your environment, but it could. And so you can go and look for that. Or, just top of my head, maybe there's a company out there that sells cars and spaceships and flamethrowers, and they get attacked and there's crypto mining going on in their environment through a Kubernetes console, right? So that's actually our day 2 story. So I don't want to steal Ryan's thunder for that when we talk about that another day. But there's really some complex ways in which an attacker can gain access to these environments, lots of different ways, and we try and map those MITRE attack techniques to those. All right, so all the stuff that's happening inside your environment, or at least a lot of it, you probably can pull from the API log. So what does that look like? In AWS, the service is called CloudTrail. It's been there since 2013. CloudTrail collects all of the calls across that API and stores them in logs and then serves them to you in a couple different ways. That the CloudTrail is the service. I don't know why they didn't call it Cloud Log. I feel like that would have been easier, but it's CloudTrail. CloudTrail has some nice capabilities by default. First of all, 80 days of log data are always available to you. You don't have to store them. You don't have to do anything. They're there. You can go and query the service and get 80 days worth of logs. If you want more than 80 days, you can store them in your own S3 bucket. And most companies and organizations are taking all the CloudTrail data and storing it in a protected S3 bucket so they can do long-term log analysis. But if you're doing threat hunting or you're doing real-time detection, it's very easy for you to make calls to CloudTrail, the API service, to get logs about the API service. Yeah, it's a little bit inside each other, but yes, that's how you do it. So you can, it's actually really easy to make, it's kind of easy to make those calls. You can also do it through the GUI. So AWS and Azure both have these GUIs that give you some access to look at logs. And this is what CloudTrails looks like. It's not great. It does a couple things really well. So if you know exactly what you're looking for, it's a really quick and dirty service to do that. At the top, there's usually a filtering, and you can only filter by one thing, which I'll show in a second, what you can filter on. And then down below is kind of the list of everything. You can also do it by time. So this is great about if something's happening right now, you can say, all right, over the last 30 minutes or an hour or whatever it is, go show me all of the events that have this feature. What the feature that you can look at is either by event name, such as ListBuckets, or describe EC2 instances. You can do it by user. So if you know the user, such as on the screen, you can see my handle, CyberGoof. So I can look at everything that CyberGoof Shaun has done, which is probably a lot. Just clicking through the GUI generates a lot of API logs, which makes it hard to look for. It's just kind of what we got to figure out how to do. But these are the things that you can search for inside of the GUI. When you look at a CloudTrail log, what you're looking at is a JSON data about a particular instance of a query or a command that was coming through the API. So in this particular case, it's probably me, somebody, I did a describe instances, which is tell me all the EC2 instances inside your environment. And so you can do that from, your console or however you're going to give me all these EC2 instances. That action is recorded as a single event. Now, what's not recorded is the data that you receive. So if I say, give me all my EC2s or all my virtual machines, and I have 5 virtual machines come back and they have names and startups and all that, none of that data is in there. But the fact that I made the call and the fact that the call returned, it was successful, is what's being tracked inside of the cloud log. There is a ton of information in this CloudTrail. I like looking at this stuff because before, in your on-prem environment, in order to know exactly what everything is happening, you would have to put agents collecting logs in every one of your virtual machines, and you would have to look at network traffic. So how many of you are having to deal with network traffic, right? Or are trying to figure out what's going on in your environment with network traffic? I mean, it's difficult. It's a lot of work. I've done it before. It's just a lot. And you probably have really fancy, nice tools to help kind of distill the good stuff from the boring stuff. But pulling that network information, it's a lot of data and it doesn't have a lot of context. In CloudTrail, you have this capability where all of my actions to my resources are going through a central location, and it's collecting similar information about every one of those calls. Who did it? What role they were using? What's their key information? When they did it? What's the IP address that it came from? What call did they make? And was it successful? Meaning, if I, Shaun, do not have permission to list all of the virtual machines in an environment, then I will see that, hey, Shaun attempted that, but it failed, right? So you'll get that kind of information. But this is just a tiny snapshot of a large amount of information that can be pulled from your environment. If you're doing this when on-prem environment, you're pulling that network traffic, and some of you are probably trying to take network traffic from host logs and combining them so you can tell a story. And you know how hard that is, especially when you have different kinds of pieces of information, or especially different kinds of deployments. What I really like about the commercial cloud environments is that you're kind of buying into a product set, right? And so the integration across the product set is very similar. So you're going to be able to make some calls across different kinds of services like S3 buckets and EC2s, and you can do it in a very similar way. So in a particular case of Erratic, the thing that she was able to do was list all the S3 buckets. So if you do this on the console, this AWS S3LS, that means list all my S3 buckets, and it will give you a list of all the S3 buckets. This is happening in your environment all the time. Every time you go into the AWS or the Azure console and you say, let me look at my buckets or my data store, that's a list. There's all kinds of stuff happening in lists. So we've got to kind of figure out what's important and what's just kind of normal. So going back to our screen from before, I can go and say, show me every time there's a list buckets, and you're going to see all this kind of information. If I dive into it, there's some things that are kind of interesting about this list buckets. The bottom one here, the AWS config, that's an AWS service that is doing monitoring and evaluation of your environment. And so it's making calls all the time. So we got to forget about that, right? There's the username of CyberGoof. That's, that would be my user. I've logged in as a human. I've been given permission to list buckets. So I probably will see that. But there's another user in there. It's an I dash. So what's I dash and a long number with letters? That's a virtual machine, right? So that's an EC2. So what I have in this particular case is I have an EC2, which is a virtual machine that's got some program on it that's running the ListBuckets call. I'll be honest with you, that shouldn't happen very often. If you've got an environment where you're deploying applications onto a virtual machine, then the application actually should know the bucket it's going for. So telling me all my ListBuckets probably is not something that would normally happen. If this was deployed, now in Eradic's case, she actually was able to do ListBuckets from that EC2. But let's say that we've got another EC2 and someone attempts to do ListBuckets. It should fail because maybe you haven't been given permission to list all my buckets. I mentioned before, but you can see this access denied, or you can see that, hey, someone attempted something and it failed. Now, if you have humans in your environment that have, limited access, maybe they're sysadmins, so they can only deal with the EC2 buckets, or maybe there's somebody that all they can do is auditing, you might see them attempting to do things that they're not supposed to. And the GUI is just going to say, hey, you can't do it. And that might be okay. But compute systems, which is what actually looks like, even though Erratic is a human performing the calls, she stole the key information from a virtual machine. So AWS thinks the virtual machine is making the call. What's interesting, though, is and I'm not highlighting it here, but the source IP. Hey, there's a virtual machine, but it's not coming from AWS. That should not happen, right? So there are some clues that we can pull in this particular Capital One attack to try and identify that, hey, there's something going on that should probably not happen in a compute system or a compute environment that's laid out in production. Now, click, click, click through the console is not always really great. So we need some better tools. Amazon has a service called Athena, and they've got some nice capabilities for you to say, hey, I want to look at my network logs, or I want to be looking at my CloudTrail logs. Go and run these in Athena, and that gives you a SQL-like query resource. The other thing you could do is you could just query the AWS service itself, the CloudTrail, and you'll get back a whole bunch of data. In our class, we actually have a whole section on JQ. Anybody out there fans of JQ? I'm liking it. I love it. I'm not awesome at it, but I'm getting better at it. But JQ can, I got some people in the chat saying, yeah, they use it. Great. JQ is great because it can take all of this JSON data, which it's a lot, and you can start having it look for multiple things, or saying, instead of just, hey, tell me all my ListBuckets, tell me all my ListBuckets that were created by a user that starts with I dash that failed, right? Oh, I see some people say JQ rocks. I like it. Yeah, JQ is awesome. And so, so JQ and other services, or you might take all your CloudTrail and shove it into Splunk or some other awesome service where you can do querying. But the idea is to be able to look at things that an attacker is doing, such as cloud discovery. When the attacker is doing the cloud discovery, it's probably failing for a lot of it, because hopefully whatever the attack service is not an admin, they didn't get admin access. That's actually worse. But you can start seeing these failures and start kind of investigating. And maybe this is tipping you off, hey, I need to go and look a little bit further in the service. So that's how AWS does it. I'm going to now turn it over to Ryan, who's going to talk about how we would do this in Azure.
All right, thank you, Shaun. So like Shaun was mentioning here, I'm going to try to attempt to do what he had just done with AWS and explain how Azure's API activity can be discovered as well, just like we saw with AWS. And I even have a slide, like if the Capital One attack were to happen in Azure, first of all, what would that attack look like? Because the way that it was done in AWS just is not possible in Azure. That's a good thing. But you're going to see there's going to be some fallout to this, though, as well, that if it were successful, we may not have as many logs at our disposal that you natively get within AWS. But I don't want to spoil that. I first want to talk through Azure's APIs, right? So Azure calls their actions, if you will, like the thing you're trying to do in their environment, they call a resource provider operation. So again, just a fancy way of saying, what is the API call that's going to occur in that environment? So if I'm creating a virtual machine, for example, using the Azure portal, I'm going to be sending a series of these operations towards that Azure API endpoint And if my user is allowed to do that, like with these, I'm going to be sending what's known as a bearer token to say, here's my credentials, here's what I want to do, here's some other data about what I want to do. And if I'm allowed to do that, the API endpoint will take that and pass it off to the appropriate service. The thing will happen, and they'll send me back a response, right? Like VM created or what have you, right? And there are a large number of these. I did the math like an hour ago just to see how many of these API calls there could be in an Azure environment, and I'm quite stunned. There's over 11,000 of these, right? So that's a whole lot to keep track of. What I do like though with Azure is they're pretty well descriptive about what they actually are, right? They break them down pretty nicely. Like it's not like ListBuckets or console login, which are pretty descriptive in and of themselves, but sometimes you don't know exactly what service those actions belong to. And if you see here on the slide, on the bottom, that little black and white graphic I have, you can see like for this example, there must be a DB for MariaDB service, right? A database service for MariaDB. And here's just a few of the things that you could be doing, like reading, writing, deleting servers, things like that. Pretty well descriptive here. I actually acquired that using the command that you see from using the Azure CLI tool. Something we'll do in class as well in 541. There's a lot of what we call command line kung fu going on in that course. So I sliced and diced the data after I ran this AZ provider operation list through one of Shaun's favorite tools, mine as well, JQ, just to spit out what these unique actions are, operations, I should say, are in the Azure world here. But with that, like, where do you go to actually see this activity in the Azure environment? Well, unlike, it's not called CloudTrail, right? That's AWS's thing. In Azure, they have what's called the activity log. So this is where most of your API activity is going to happen and be recorded in the Azure service. Now, there is a problem here. If you read that first bullet that I have that I call out, that's where you're going to see a huge difference between CloudTrail and the Azure Activity Log. It only provides create, update, and delete activities. So if you're familiar with the acronym CRUD, right? It stands for create, read, update, delete. There's one of them missing here, read activity. So if I were, like in Shaun's case where we were reading buckets in AWS, so let's do the equivalent in Azure. I'm reading from storage accounts or blobs or whatever, whatever storage that's in Azure, that's not going to show up here in the activity log. If I'm logged into your account and I start just poking and prodding around all the different services and seeing what you have and stealing all your data and getting more and more recon done and performed in that account, most of that, if not all of that, is just not going to appear in the activity log. So it is limited on what you see. But if an attacker lands in your environment, or you have a rogue admin, or someone's doing things that are against policy and they're making alterations to your Azure services, you're going to see that here in the activity log. And it's pretty rich with its information. As you can see here, it's in, it can be captured in JSON format. You can get a lot of great details about it. But to be honest, the vast majority of the fields, if I were an analyst, for example, I probably wouldn't find too incredibly useful. But I will highlight later a few slides here. In most cases, some of the more appropriate fields that an analyst would want to get their hands on if something inappropriate was happening in this Azure environment. Now, just like Shaun showed you with CloudTrail, you can use the GUI, the portal in this case for Azure, to go through and start analyzing this data, see what is changing in your Azure environment. Again, not what's red, but what, if something's being updated or deleted or created in the environment or modified, whatever, you can view most of that data here in the activity log. It's pretty high level stuff, right? You get things, and you can change what columns are displayed and things like that, what data would be most useful to you. But here's what you see by default in Azure. You'll see things like what was the operation name, like the proper name for it. That's similar to like your list buckets, right? Very descriptive about what it's doing. Like here, you can see obviously someone was deleting what's called a resource group. If you're not familiar with that in the Azure world, right? A resource group is more or less a collection of cloud resources. They're typically used for multiple different reasons. I like to use them for lines in the sand, if you will, for IAM, right? Identity and access management, to say if assets are in, like cloud resources are within this resource group, you're allowed to access those, right? That's a good segmentation point, if you will, within Azure. Another one might be you create a project. You're going to set up a new dev web server or something like that, you might create a dedicated resource group and have your VMs as part of that, the disks for your VMs as part of that resource group. If they need storage, maybe the storage containers and so on, to all be within that same resource group. But when you do actions like deleting an entire resource group, you're going to have an awful lot of API calls and API activity happening within Azure itself. Long story short, and this is one of the reasons I prefer, in this case, Azure over CloudTrail's GUI, is because they have this thing called a correlation ID. If you perform one action and it's actually doing a lot of different things within Azure, they kind of lump them all together, like deleting a resource group. You're not just deleting the resource group, you're deleting the VM, you're deleting the virtual disk, the network security groups, possibly, the storage container, just anything in that group. All of those actions will all be correlated together for you. Something that in CloudTrail, you'd have to try to do the correlation yourself, like what else happened around this time in the Azure or the AWS environment and so on, right? So that's one thing I do like about this. Also, you can filter down on this data to do some searching within that view that I just showed you earlier. It is limited, just like CloudTrail was limited as well. You only have select things that you can search on. And like in this example, let's say we want to see all the things that happen to a virtual machine or all of my virtual machine activity. They have free-form text that you can type out. If that text is captured in those log entries anywhere, it's going to display the relevant log data, which can be quite useful. Like if I have an indicator saying this virtual machine is doing very suspicious things all of a sudden, I can filter down to that particular machine, or maybe I have an IP address or a username or something, right? Just some indicator of compromise, if you will. I can start free-form text searching for this. But you can also narrow it down to specific things that are predetermined by Azure, like which resource group this may be a member of. Like if I'm pretty confident that this attack only affected things within this one resource group, I can narrow down my search there as well. Even time spans also, right? Because this might have happened, 40 days ago. You don't have to sift through pages and pages and pages of log data if you capture everything, or by default, it's only giving you 6 hours anyway. You're going to have to expand that search or play around with the time span filters within this activity log service. So pretty customizable, to be honest, but in my opinion, and I think Shaun's as well, nothing beats going to the command line and just slicing and dicing the data for you, which again is why we tend to focus on that on the hands-on portions of the 541 course, just because you could do things in a much more efficient manner once you're spun up and understand the tooling that you're using in that case. Not to discount the portal, right? It's good in a pinch. I would just rather use the command line when I can. So anyway, this is the last bit that I wanted to mention on the portal itself, and then I'll get into a comparison study here where we had some activity happening in Azure. Let's get to the bottom of it using the portal, and then I'll transition over to that case study discussion, the Capital One-like attack. All right, so here in the portal itself, you can also view the JSON representation of that data. Same thing you can do within CloudTrail. It's very, very rich data. It's got a ton of different fields and values and such that you can search on. But as I was mentioning, not all of it is super, super relevant to your average analyst. Now, am I going to tell you can always discount particular fields? No, but in most cases, right, what I've included here on this slide are what I call my top 8, right? Not to discount everything else, but in general, here are the types of things that I would first want to look at when sifting through this data. Like, what was the action? What was the API call, if you will? Were they deleting the resource group? Were they deleting storage? Were they, were they overwriting my log data that exists in storage to kind of cover their tracks? That kind of stuff, right? Those actions would be very, very useful to know. But just like Shaun was showing earlier with his CyberGoof username, right? You can also see the user account that was taking these actions and performing these actions in your Azure environment. They call it a caller here. So that's the email address, if you will, of that account that's doing that activity. Also, you can look at the name, the claims.name that I highlight here as well. That's the human readable name, if you will, of that user. So like Ryan Nicholson, for example, would show up under the claims.name, that nested field underneath claims. IP addresses, the correlation ID, timestamps, and so on, right? So those are what I consider my top 8, but there's a lot of data though that you could potentially sift through here in these logs. Would definitely fill up this slide and several other slides, and who's got time for that, right? All right, so in practice here, how would you use that activity log? So I'm just gonna lay this out again. It doesn't have to do with Capital One yet, but let's just say, for instance, we've got a very sensitive system. this case, it's log server, right? Very, very cool name server, right? It's our one and only log server, but we lost it, right? But we didn't lose it. It got deleted. Something happened to it. It's no longer in our account. That could be, it could be malice, right? An attacker covering their tracks. A good way would be destroy the log server. Maybe our SIM is running on that server, our security information and events management system. Like maybe we're running Splunk on it or QRadar, or we rolled our own Elastic Stack or something, right? It's no longer there, right? So this could be something that the attacker ran, this CLI command. Now the AZ VM delete command does exactly what it sounds like. You have to feed it, of course, some flags, like what's the name of the server, what resource group does it belong to? But if you have permission to do it, it's going to delete that virtual machine, right? So that could have been what happened. So let's move over to the portal, the Azure Activity Log in the portal, I should say, and see if we can sift through our data and see what comes up. So, spoiler alert, I actually did this in Azure, so I already knew that this happened, but let's say we didn't, right? So we can do that free form text search, like I'd mentioned before. We know what we're looking for. We knew our normal environment consisted of a virtual machine called log server. So let's search for that, see any event that happened to log server. And we can narrow it down even further. Like if we assume that server was deleted because it's no longer there, we can look for specific operations. In this case, we're looking for the delete virtual machine, and it's kind of cut off there, as you can see, but you can also search for that full resource operation, if you will, the full name of that, if you know what you're looking for, or you can search for the human readable name as well. Right. And also, let's say we have a pretty high confidence that it just happened, right? All of a sudden we had this alarm sent via email saying, hey, I can't search your logs anymore. Like, what's going on? I was in the server, it's no longer responding. It happened within the last hour. Or maybe it happened several weeks ago. We can adjust our time span here. But upon doing that, let's see if we can uncover who did this or some context around what happened in our environment. So here, final slide for this is we found our delete virtual machine. Now, another spoiler alert for 541, which I have an environment built for that, by the way. We have a Sherlock theme going on, if you haven't picked up on that yet. So we have some villains in our class. In this case, it looks like we had a villain in our environment, this user account or caller, if you will, Moriarty at, in this case, it's ryanic.com. I was just repurposing an old domain name here. But it looks like 8 minutes ago, right around when we started having those issues popping up in our environment, a virtual machine was deleted. And we can dig further into this, look at that JSON data, and get to the bottom of this and say, look, the name again was Moriarty, pretty confident that user, maybe that user never existed. We've got more research to do. Maybe an attacker created a backdoor into our cloud environment that has pretty open permissions. I mean, they're able to delete virtual machines, right? Maybe that's a backdoor. Maybe that's a rogue user. Maybe Sherlock and Moriarty had a falling out, and now Moriarty's just ransacking that environment. Who knows? Also, we can pick up things like the IP addresses and much, much more, right? So now we can get a sense of more context around what was going on here. We can continue to pull in more indicators and scour the rest of our logs and see what else was happening around the time of this virtual machine to figure out how they got in, what they were doing once they were in, and things of that nature. Or maybe Moriarty's just having an off day and made a mistake, right? But it's at least leading our investigation here. We found an artifact that we need to take and run with. All right, so my final slide, other than talking about some of the SANS curriculum really, really briefly, is what I call a Capital One style attack in Azure. But to explain this, I want to unpack a little bit more what happened during the Capital One AWS attack, that abuse of what's called the IMDS, the Instance Metadata Service in AWS. So that service, there's two different versions in AWS. There's version 1 and there's version 2. Now, by default, both will work in EC2. So if you have what's called an instance role, which is essentially your permissions that instance can perform, assigned to that EC2 instance, that instance or anyone that can convince that instance to make this call, as Shaun was alluding to, if they query the IMDS service version 1, just out of the box, like they can run curl, for example, against it, and it will return security credentials, the AWS access key, secret key, and session token. The three things that are needed to pretend to be that virtual machine and do all the things that VM can do. There is a better iteration of IMDS called IMDS version 2, which you can enable, which was part of the whole lessons learned from the industry when the Capital One attack happened, is to enable that disable version 1. The difference is when you send that request asking for credentials, you have to supply some header information, which if you're familiar with HTTP requests, like if I go to www.google.com, I'm not just doing the get / and then targeting that IP address. I'm also sending a host header where it'll say host : www.google.com. That's more context to my request. That's the virtual host that I'm searching for. With IMDS version 2, AWS requires you to send an additional header as a protection mechanism, because if I'm tricking a web server to, instead of going to another web server to retrieve a file or call S3 and retrieve a file using the HTTP link for it, it's not going to be adding that header on your behalf. So that's a pretty good protection there. So now if I'm an attacker, I'd have to compromise that system or perform some other kind of web application attack, like command injection, for example, where I can run local shell commands from the outside. And I'd have to add that header that Azure, in this case, is looking for. The reason why I bring that up here is because Azure doesn't have that version 1. That attack is not possible the way it happened in AWS with Azure. You have to do these other things that I'm laying out on this slide right here. First of all, you have to have their equivalent of an instance role applied to that system, which is in their terminology is called a managed identity. You give it permissions through that particular service. But once that's set up, you'd have to, again, perform a different attack, either compromising the system as a whole and establishing a shell connection with it, or doing command injection instead of the server-side request forgery technique of remote file inclusion, right? So that's going to be quite different there as well. But your job's not done yet. To pivot over to storage in this case, those credentials that you acquired through the managed identity are not good enough. You have to acquire what's called a connection string and do some signing of your request just to pull anything from storage. It's a lot of heavy lifting that the attacker would have to do once they land in this environment. That sounds swell, right? You want to move all your AWS to Azure right now, right? Well, that's not the point here. That's just showing you that certain techniques don't work in certain cloud environments as easily, right? Certainly not impossible. I laid out how you could do that here. Just a lot of extra work on the attacker side. So Azure, I guess you could say, has a little more defense in depth, and it just makes it harder on the attacker here. But with that said, a lot of the stuff that the attacker would be doing during this attack is not logged by default, by the way. Remember, all the way back when I was mentioning the activity log, how much read activity would you see there? Nothing, right? But that's the default. That's why I said default logging is minimal here. You can enable more logging within the Azure environment, just like you can in AWS. So as folks are accessing storage, for example, you're not going to see that in the activity log, but you can go into a feature that's across all of the Azure services that I'm aware of called diagnostic settings, where you can configure to say any read activity to this blob container. I want to see that activity and send it over to another cloud service like Log Analytics, whereas oftentimes a landing pad in Azure to stash your data and then be able to query and parse through that data, or send it to the equivalent of an S3 bucket, a storage container in Azure. Just there's tons of options, but none of that is on for you by default, right? Which is why when we get into 541, that's something we really try to nail as well. Like, what's a proper setup look like? And once that setup is complete and you're starting to gather all this log data, how do we identify specific attacks in these cloud environments? And just like Shaun was mentioning, we have case studies galore in that class where we break down individual techniques, see what they look like as cloud data, and be able to perform exercises, hands-on exercises to dig through and sift through that data. So I just want to throw up our boilerplate slide on the SANS cloud security curriculum here before I start taking some questions. So just a quick explanation is on the slide on what these courses are all about. Highly encourage you to attend one if you can, or if you have any kind of question about them, please feel free to reach out to the cloud curriculum directly or to me. You know, I'm definitely open to talking to some potential or even repeat students and across the curriculum. So with that said, I think I'm going to hand it over to Laura and let her moderate the Q&A, and then Shaun and myself can kind of just jump in and as needed.
Wonderful. Thank you guys so much. I would like to point out 2 updates to the curriculum slide that we have showing right now. SEC541 Public Cloud Security now has a GX certification, the GPCS Public Cloud Security Certification. And we've also released Forensics 509, which is incident response and forensics for cloud. and beta 1 and 2 are sold out. So be on the lookout for more runs of that course coming up. So for the Q&A, first question, would the attack mapping to describe SSRF be different from one for this case study?
Yeah, so it's kind of, so I don't know which the attack technique you're referring. The MITRE attack does have some information about web application attacks, and it's usually about manipulating an application. I found that the OWASP top 10 has a much better write-up on web application attacks. So that's always kind of the first place I go to. The SSRF, if you look at the OWASP top 10, which is it's a top 10 list of the major attacks against web applications, but they go into a lot of detail about them for anybody who's not familiar with them. This SSRF is actually not in the top 10. It's like 13. So that they have like these other things that are of interest. And so whenever I do these threat reportings, if it's anything that's application based, I always try to go to the OWASP top 10 because they have just so much more information about the web applications.
Perfect. Next question. Having port 80 open on that blog VM is the weakest link and allowed her to continue her attack in this method. I run into issues with our devs that don't want to only allow 443 when behind a load balancer in AWS, so ingress is load balancer port 443, then to the instance on port 80. Would a good control be ensuring the security groups in place only allows port 80 from load balancer?
All right, so I have 2 comments on that one. So the Capital One attack, you could have used port 16,000, it wouldn't have mattered because the flaw was actually in the web application code itself. So if it was encrypted, not encrypted, wouldn't have mattered in this case. I do like where your question was headed though, and you want to enforce encryption where possible, right? So you might be thinking like zero trust. I don't want to go down that rabbit hole, but that's one of the principles with zero trust is to encrypt all the things. So relying on TCP ports to try to force the issue certainly would not be a bad idea here to say like from the load balancer to the backend resource, we want to ensure that's encrypted, and HTTPS is typically going to be over 443, so we can control that traffic as well to kind of force our developers to make some kind of change. Now, if you have developers that are just going to skirt rules anyway, they may know that if 443 is just a TCP port, that's not guaranteed to be HTTPS. Like they could simply, and don't tell them I told you this, but they could, if they wanted to, go into like their Apache or their Nginx configuration, just say, listen 443, and not do anything with encryption. And it's going to look like they're sending over, encrypted channels, but it's just listening on a different TCP port in plain text. But there are possibly other ways to do that as well. Like if you have a load balancer that you can configure to only speak HTTPS to that backend, like that they have to configure HTTPS or it just simply won't work because you're talking application layer at this point. That would be a good strategy to take to combat those sorts of things. And one that comes to mind, and this is an AWS, of course, I'm not as familiar with those load balancers, to be honest, and maybe Shaun can jump in here after I mentioned the Azure front door service, for example, where you can configure the front door service to say, if I'm talking to that back end, it's got to be over HTTPS or it just ain't working, right? And I'll hand it over to Shaun to see if he had any other thoughts on that.
Yeah, I mean, there's a combination of load balancers and security groups from the network side to kind of control to make sure what you're allowed to talk to. I think if I were to look at like what the major problem was, I would say the focus on the role that allowed that EC2 to have access to all the S3 buckets. My guess is that it's probably a service that gets deployed and it tempted to go and read a configuration file, but instead they said, well, just read from everything. Like you're troubleshooting, you don't know why it's not working. And so that's, if you can kind of narrow down what an EC2 is allowed to do, then it wouldn't have been able to go and read those S3 buckets. So, yeah.
Wonderful. Thank you, guys. Next question. What's the best strategy to offload the right CloudTrail logs into a SOAR?
Yeah, so a SOAR, which is a security orchestration and automation and response services, allows you, to be able to say, here's a bunch of stuff happening. I see something that is a problem. I'm going to go and initiate an action. That for AWS or Azure or whatever service, because I think the next question was on Azure. I think there's two approaches for the strategy for it. If I don't know your environment, the best strategy I would say is to figure out what is the response action you want to take based off of an attack, figure out what data you need, and then send only that data. So if you know that you want to, I don't know what it would be, create an alert if if an IAM role is being used, but from outside the environment, then figure out exactly what data you need and then send it. Now, you might be in a case where you have the team that sends the data and the SOAR team are completely separate and the coordination is too much work. And then it may be just easier just to send all the data and then have the SOAR team kind of figure it out. But the goal is from a SOAR is that as you're figuring out what response actions they want, you're going to change your mind. You're going to add to it. You got to be able to change the logs that you're pulling in pretty quickly if you're going to do it log by log.
So for the non-technical person behind the scenes here, you may have already answered the next question.
Yeah.
Similar to the last question, how do you best integrate Azure logs into a SOAR?
Yeah, from a strategy perspective, that would be how I would recommend doing it. If you're talking about from a technical example, there are a number of ways in both AWS and Azure to identify logs and ship them to another account. And you can ship them to another account that has your source service, maybe dropping it into a bucket, and then the SOAR pulling from that bucket. But that SOAR has to then be able to have access back into the production environment. So you're kind of moving them out, moving them in. That's usually the best way technically to be able to do it.
Great. Thank you, Shaun.
Mm-hmm.
So for Azure threat detection, if I heard correctly, is best done at CLI or within native tooling?
So maybe I misspoke, but if I had my choice, right? There's using the portal and just using the limited capabilities that you have in the portal versus the CLI tools and then all the additional tools that I could run with the AZ CLI tools, for example. I would personally, and this is me personally speaking, and I'll tell you why I think this is the way to go as well. If I had to convince anyone, I prefer using the command line in that case, because I can take the results I get from that AZ command, for example, like give me all the activity logs from the last day, right? I can take that information and I can further dissect it using other tools, something I can't do in the portal. Like I can, in the Linux world, we call it piping results from one command into another as like the input to another tool like JQ. Because if I ran, say, the AZ equivalent of that CloudTrail list events or whatever it was, right, that Shaun was showing earlier, that's a lot of data that I probably don't need. If I'm only looking for like what actions were performed, I can dissect that down even further and just dump out those lists, that list of actions that were being performed, maybe by who and things like that. Just extend upon that capability, something I can't do in the portal. And this is where I get on my pedestal just very briefly here and just highly recommend, if you're going to find yourself working at any capacity in cloud, learn the command line. If you don't learn it now, I have a really good feeling that you're going to be left in the dust here very, very shortly. So if I had to like recommend anything, I would say learn Bash, because you're going to find yourself more often in most cases on a Linux system than a Windows system in cloud. Not always, right? Your environment may be purely Windows, but that's why I say Bash as well as PowerShell would definitely be two tools or two environments that I would definitely want to be familiar with when working in cloud. But I'll step down off my pedestal now and you know, because I've stopped answering the question at this point.
Awesome. Does the SANS Cloud Monitoring and Threat Detection course cover other CSPs in addition to AWS and Azure?
Yeah, so for our 3-day class, it's just AWS and Azure. I know that there are some other classes like 510 and Ryan's class 488 that do deal with Google, GSC. But our class is just AWS and Azure.
Great. There are certain cloud services logging for which is not supported by the cloud vendor yet, especially in CloudTrail. So how do you go about detecting those? Not quite sure the context there.
Ryan, do you want that or you want me to take it?
You can try it.
Okay. Yeah. So there are some services like AWS services that are not being tracked. And I have read research of ways of getting around having CloudTrail detect those. Scott Piper at one point had a list that he had created. I don't know who's keeping it up, but The best action for those kind of things, if you have a blind spot in your logging, then the best thing is to put up barriers in front of it. So for instance, I know in it seems kind of silly, but there is the service that's called, there's like a, the name dropped it, but there's a service that AWS has that gives you a whole bunch of information about your environment. And it's usually for managers. And that is not being tracked in AWS. So the best option is to make sure that in your production environment, nobody is allowed to go and log into and hit that system. Focus on those high risk environments into one account and separate that from your like web application account, separate it from your backend security account, and split those accounts, or in Azure, it's called subscriptions, but split those up so that you can protect them a little bit differently. And you've created your boundary defenses around them. And then if you have things like you're running your own web application firewall, so you're not going through the AWS and API, then you're going to need your own host-based logging on those services to be able to detect those.
Awesome. And the final question we have for today, what is the best security framework for cloud security architecture? Do you have any recommendations for a tool to assess cloud security posture?
So I'll start on this one. So I can't say there's a one size fits all like security framework out there. What I can recommend though are just some cloud native tools, right? So in AWS, you have your security hub service that you can tell it like what kind of like benchmarks or compliance frameworks that you are interested in, that you want to protect your environment or meet those compliances, if you will, because nothing worse than having an audit and you're not familiar with how you would implement those protection mechanisms in your environment and getting hammered on that audit, right? So they help from that front, but they're not going to be one size fits all solutions because those services don't understand your environment as well as you do. So there's going to be cases where there has to be additional thought put into it. Like all of my critical resources are over here. This is a very sensitive S3 bucket. You're going to have to make those determinations yourself, do those risk assessments, things like that. But the vendor resources are pretty good in highlighting some things that maybe you didn't account for, like that public S3 bucket that you didn't even know was public can pop up in some of these tools like Security Hub, Azure Security Center, and there's a load of third-party tools out there as well, especially if you find yourself in a multi-cloud situation where you're using more than one vendor. One that I want to, I don't have any vested interest in this tool or anything, but one I've played around with quite often is from Aqua Security CloudSploit, where you can tie that in to your various cloud environments, and it can assess it on a regular basis, and again, point out those security architecture flaws that they recommend that you address. But at the end of the day, again, no one knows your environment, hopefully, better than you do. So there's going to be some manual calls that you need to make and some consideration and some additional thought that needs to be put into what the right architecture for you from a security perspective actually is.
Yeah, and I'll just jump in. I like the CIS. Not only do they have their set of critical controls, but they have benchmarks, and they also have audit scripts, and they're usually really easy to understand and kind of make use of. I also, Cloud Security Alliance is another place you can go. They have really big, detailed compliance worksheets that you can look at. But really, the big one is that both AWS and Azure have something that's like called the well-architected framework, and there are best practices, and in some cases, tools to help figure out, are you implementing security, elasticity, financial savings, that kind of stuff in your environments. And so those are three places that I always go to.
Wonderful. Gentlemen, thank you so much for your time and your knowledge. And thank you all for attending. We hope you come next week to our CloudSec Next annual free summit. It's 2 full days of cloud security training. So join us then and have a wonderful rest of your day. Thank you so much.